What if I told you that scientists just recorded the absolute clearest signal of two massive black holes colliding over 1 billion light years away? Welcome to this explainer. Today, we're skipping the long preamble and diving straight into the climax of a cosmic mystery over 1 billion years in the making. We're talking about a record-breaking discovery that proves Einstein right in the most extreme way possible, and it's literally changing how we understand the entire universe.
So let's set the stage here and talk about the actual sound of a cosmic collision. I want you to imagine the most violent, cataclysmic event imaginable, happening in the darkest depths of deep space. You've got two invisible, unbelievably dense objects locked in a death spiral, violently crashing together. It really begs the question, right? What does a black hole collision actually sound like? Well, thanks to some mind-blowing recent breakthroughs, we finally have an unprecedented, high-definition answer to that question. Physicist Keith Mittman has this absolutely brilliant analogy for it. He says that when two black holes merge, the collision rings like a bell, emitting specific tones characterized by a frequency and a damping time. So it's not a loud crash that we'd hear with our ears, but rather a ringing vibration echoing out through the universe. But here's the catch. To hear a cosmic bell ringing from the opposite side of the universe, scientists first had to build an ear big enough to actually listen. Because we aren't listening for sound waves traveling through the air. We are listening for gravitational waves. These are literal distortions rippling through the fabric of reality itself. When objects this heavy crash, they stretch and squeeze the very space that we exist in. It's wild to think about. And to catch these impossibly faint ripples, we rely on a massive global ear called the LVK network. This includes LIGO in the US, Virgo in Italy, and Kagra in Japan. This huge global network works together to triangulate and pull thousands of faint signals out of the static of the cosmos. Just to give you an idea of the scale, in their fourth observing run alone, they processed a staggering 5,466 candidate alerts. Which brings us to the main event. A record-breaking signal that completely shocked the astronomical community. On January 14, 2025, the network detected an event named GW250114. Two massive black holes, one 32 times the mass of our Sun and the other 34 times the mass of our Sun, smashed into one another over 1 billion light-years away, sending a colossal shockwave right at Earth. And it produced this number, 76.9. That is the signal-to-noise ratio of the event. Now, in the world of gravitational wave astronomy, that number is absolutely enormous. It means this was, without a doubt, the clearest gravitational wave signal ever pulled from the background noise of space. It just stood out loud and clear above all the cosmic static. Because this signal was so unbelievably loud and clear, it gave scientists a once-in-a-lifetime opportunity. For the first time ever, human instruments could resolve distinct, pristine details of the crash that were previously just lost in the noise. So let's break down the anatomy of the crash itself and look at the fascinating physics of what happened right after the impact. A black hole merger happens in basically 3 distinct steps. First, you have the inspiral, where the black holes orbit each other incredibly fast. Second is the merger, which is that violent collision into a single mass. And finally, the ringdown, those lingering vibrations radiating outward. And it's that final step, the ringdown, where the real magic of this particular signal lies. Thanks to that huge 76.9 signal clarity, physicists were able to isolate not just one, but 3 distinct tones ringing out from the newly formed black hole during the ringdown phase. Resolving 3 completely separate tones from a single event, that had literally never been done before. Now, finding those 3 tones wasn't just a neat audio trick. It set the stage for the ultimate cosmic stress test. This was a chance to test our greatest physics theories under the most extreme conditions imaginable. On one side, you have Einstein's general relativity, which says each of those 3 tones must predict the exact same black hole mass and spin. And on the other, you have Hawking's area theorem, dictating the physics of the newly formed surface area. Both of these theories make highly specific predictions. And you know what happened when the data came in? All 3 tones yielded the exact same mass and spin combination. Every single measurement perfectly aligned. It flawlessly verified Einstein's predictions and confirmed Hawking's theorem. They were both proven absolutely right in the most extreme, chaotic environment in the universe. No way around it. That is just incredible.
Let's just take a step back for a second to really appreciate how fast this field is evolving. It's staggering. In 2015, we celebrated the very first faint detection of gravitational waves. Fast forward a bit to 2024, the O4b observing run kicks off with Virgo back in the network. And then, by 2025, the GWTC5 catalog is released, boasting 390 total confirmed events. In just 10 years, we went from zero to a massive catalog of confirmed cosmic collisions. You can see how exponentially our observations are expanding. The GWTC4 catalog added 128 new events, finding massive 130 solar mass black holes. Then, GWTC5 adds another 161, including our record-breaking GW25014. With every single run, we're capturing heavier, clearer, and far more complex binary collisions. We are officially in the era of statistical and precision gravitational astronomy. This is a real game changer. It transforms black holes from these silent, empty voids into dynamic, ringing instruments. We aren't just guessing at these events anymore, we are actively listening to the violent symphony of the cosmos in high definition. So, I'm going to leave you with this provocative thought. What other cosmic mysteries are we going to unlock now that we can listen to the universe with this kind of clarity? If this is what we can hear right now, what astonishing, universe-altering discoveries are just waiting for us in the next cosmic ringdown? Thank you so much for joining me on this explainer. Keep listening and keep wondering.